We're going to be trying to answer a big question with this activity. And the question is, instead of using tangents and slopes of tangents to find instantaneous rates of change to a function, could I come up with a slope function instead that would predict it for me, instead of going to all that work of making tangents and measuring them? So, if I'm given a function, is it possible to find a slope function that's going to predict instantaneous rates of change for me? So on the left, as you can see, I have an ordinary function. It's just a nice parabolic arc. And the question is it possible that we could find a slope function for it? Let's see what that really means. So if this is going to be my slope function, ordinarily what I'd do is I'd take some tangent slopes to the parabola. So when x is equal to 2, I can see that this tangent slope is 0. So over on my slope function, what I'm going to do is put a point at 2 and 0, 2 being the x-coordinate and 0 being the slope. And what if I kept going and I said, oh, well, when x is 1, I can see that the tangent slope is 2. And I went over here and put an appropriate point on my slope function, 1 being the x-coordinate, 2 being the slope. Now, is it possible, can I make the leap that it's possible for me to say, I can make a function that's going to predict the slope for that parabola for any value of x? And that's what we're going to be trying to answer with this activity.